our new unit on statistics. And this first particular lesson is on a special graph called the scatter plot. So what is a scatter plot? Well, scatter plots are graphs that are used to that use plot points to display numerical data with two variables. Sometimes they call that bivariate, which is just a fancy way of saying two different variables. Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or associations between the variables. For example, if we have some scatter plots that look kind of like this, we know that as the data increases as you go to the right on the graph, that is called one particular association, an increasing. As one variable goes up, so does the other one. And the next one, in a negative association, as the x value goes up, you go to the right on your graph, the dots are dropping lower and lower in the y direction. Sometimes we do a plot of data and the dots are just all over the graph and there doesn't appear to be any relationship, so we just say there's no effect on the change in one variable has no effect on the second variable. Now some of these types of plots could include something like how many hours of sunshine during a day and what's the temperature after so many hours of sunshine. And usually the longer the sun has been out, the temperature would go up. So you can see how those would be associated. All right, we can also describe the strength of association seen on a scatter plot and whether the association is linear or nonlinear. So if you look at these, they've got different patterns. So if data points are close together, the association is strong. And if the data points are widely spread, and the association is weak. You notice how these points are a little closer together. These are a little bit more spread apart, so it's kind of a weak association. We also notice that if the points kind of, even though they're not exactly touching each other, if they have a tendency to go up in a line, that's called a linear relationship. And if that is the case, if you have data that has a linear relationship, you can do a lot of things with that data to predict future behavior of the data. However, if your data kind of goes up and then down, doesn't have a particular straight line effect on it, we call it nonlinear. So let's take a look at these. Use the scatter plots A through D to answer these questions. So which scatter plots show linear association? So we're going to look for the data that appears to be forming a straight line. So if you look at B and C, even though they're kind of not loose or not tightly tied together, but both of those have a linear association, right? Which scatter plots showed nonlinear association? Well, B and C are the ones that showed linear, then A and D are probably the ones that don't show linear association. Which scatter plot shows the weakest association? So that would be C, because the points are more spread out. Which scatter plot shows the strongest association? In that case, it's probably A, because all the dots seem to be really close together, and then A and B would come in second. But right now it looks like A, the points are the closest together. All right, so we want to show you how to construct a scatter plot. So we have a nice graph here that is measuring the distance from a basketball hoop in feet and the number of baskets made. So Jared's basketball team stood at various distances from the basketball hoop and counted the number of baskets they were able to make in 30 seconds. Use the data in the table to make a scatter plot. Then answer the questions that follow. So when he was 15 feet away, 2 baskets were made. So you go over here to 15 feet and go up and make a little dot at the number 2. 45 feet away, 2. So 45 feet away, 2. 30 feet away, 5. So over to 30 and up to 5. 40 feet away, 1. 30 feet away, 4. 10 feet away, 10. They were shooting 100% on that one. 35 feet away, 3. 10 feet away, 8. And 35 feet away, 5. So 35 feet away, 5. All right, so there appears to be kind of a negative association there. The further away you are from the basket, the fewer baskets you make, as a general rule. So now we need to answer some questions about this data. So describe the type of association seen on the scatter plot. So it was a negative association. That's because the further away from the hoop, the fewer shots you made. Are there any points that don't fill the overall trend of the data, or don't fit it? And I thought there was one. The one at 15 and 2, that's kind of an oddball right there. So let's go ahead and list that. 15, over 15 and up 2, that happened to kind of be out of place. Describe any unique observations about the shape of the graph. Well, other than that oddball one, it has a tendency to be linear, okay? So linear in general. All right, now use the scatter plot to label each statement as true or false. As the distance from the hoop increases, the number of baskets made decreases. True. As the distance from the hoop decreases, the number of baskets made increases. Well, wouldn't that be also true? As the distance decreases, doesn't the number of made baskets go up? So that's also true. Good thing we read carefully so we can get those right. Okay, now scatter plots may include points known as outliers, and my display clusters or may display. We should change that word, huh? And may display clusters of points as described below. So, outliers, a point that does not fit the overall pattern or trend of a scatter plot is known as an outlier. Which player represents the outlier in the scatter plot above? So in our scatter plot we were looking at, what player was 15 feet from the basket? That would be Mark, right? Oh no, it would be Jared, 15 and 2. Did we skip one? 15 and 9? I think we may have skipped a point back in there when we were plotting those. 15 and 9. Did we skip any others? 30 feet and 5. I'm just double checking. Sometimes you have to double check what you've done to make sure. Okay, looks like that's the one we missed. So this one's kind of the oddball. So that would be Jared, right? All right, so, and that meant a group of players stood 15 feet closer to the hoop, while the second group stood 30 feet or further from the hoop. So that's where the data was kind of clustered. So what does that mean? Let's look at that. So there's a lot of data up here, 15 feet and closer, and there's a lot of data over here from 30 feet further out. There doesn't seem to be very many people in the 20 to 25 foot range, so that's kind of known as your clustering, all right? All right, let's make another one. So the population of 10 cities and the number of elementary schools in the city was shown in the table. So let's graph that. Now keep in mind on the bottom we're talking about population in thousands. So if it says 85,000, then that's going to be somewhere between 80 and 90 in that area, okay? So let's start with our top number, 76,019 schools. So 70 and 19, that's going to put us right up just above 18. So you're kind of approximating where these plots go. Over 60, up 17, that's going to be just below 18, right? 35,000 and up 11, so 35, 11 is going to be just below 12. 73,000 up to 22, 73,000 up to 22. 51,000, 51,000 up to 13. So we just kind of graphing. Now, are we perfectly in place? No, we're just kind of getting as close as we can. We don't have the tools to get too precise here. 78,000, little under 20,000 up to 24 schools. That's a nice area because they have lots of schools for the kids, right? 25,000 and up to 10. Okay, right about here. 13,007, so 13,000 up to 7. 20,000 up to 18. And then 85,000, 21 schools. So right about there. Okay, describe any association and conclusions you can make from the graph. Well, it's a positive association. More kids, more schools, right? More kids. There are more schools. And if you wanted to get really technical, you could probably actually use a little average of population in schools to find out how many people there has to be in order for the school district to build a school. Does the graph appear to have any outliers? Yes, it does. There's one right there, and that is the one that had 20,000 people had 18 schools. That had way more schools than most of the other areas that had similar populations. Okay? Yeah, so 20,000 had 18 schools. Now keep in mind that's 20,000 people, so you're looking at 18 schools. That's approximately 1,000 people per school. But not all of those people are school-aged people, right? There are a lot of adults there. Does the graph demonstrate clustering? Explain. I would say no. The data appears to be spread out. There might be a little cluster there and one dot there, but those are not considered real clustering. Okay? All right, that's kind of the kind of questions you could be asked after you plot or get a look at a plot from a scatter plot. All right, let's answer a few more questions. These are some of the questions you might see on today's ALEKS assignment. Which data set appears to show a positive linear relationship? Well, that would be number 4. See how, in fact, that is lined up very nicely. Which data set appears to show a negative linear relationship? Well, that would certainly be figure 2. What data set appears to show a nonlinear relationship between its variables? That would be figure 3. And technically speaking, you look at figure 1, that doesn't show linear or nonlinear either. It's just kind of a spread out. How about the 4th choice? Which data set appears to show no relationship? Well, that would be the best description for figure 1. So our assignment is number 108 on ALEKS, scatter plots. And we've got work papers in the back of the room, and you can show what work you can, but most of this you're going to be looking at the stuff on Alex and just doing it on there, and certainly submitting a screenshot of your score. So thank you very much and good luck.